Okay, good morning. It's July 4 already here in the United States of America. Okay, may random topic for this morning. Anyway, it's July 4. Happy Independence Day, USA. Okay, my random topic will be integration. Okay, it seems YouTubers are saturated with algebra problems, so let's go integration, okay? uh, we are saturated with algebra. Okay, let's proceed with this integration. Okay, the problem is evaluate the integral, the square root, the terms inside is 1 minus the square root of y all over y, all multiplied by dy, and what will be equal to. We are asked to evaluate that integral. For integral calculus, there are lots of variations of problems. So if you are an intelligent integrator, okay, you must have to minimize the time in order to for you to give the correct solution for the problem. Okay, let's try to bring out the solution. On the first look, it seems the problem is complicated, right? But by using the so-called laws of exponents under algebra, college algebra, okay, we'll try to simplify first the given term without the integral sign. The square root of 1 minus the square root of y all over y, okay, can be written as the square root of 1 minus the square root of y, right? All over the square root of y. We are given a first term divided by a second term, and this is raised to a power n, right? That's laws of exponent under algebra. And this can be written as e raised to n all over b raised to n. Where b raised to n is actually the square root of y. Or if we eliminate the radical, excuse me, square root of y can be written as y raised to 1/2. And this e to the n is the 1 minus the square root of y, also raised to 1/2. Okay? So this right hand side emanates from from the laws of exponents under college algebra. Okay? Pre-algebra, college algebra, it's the same as algebra. Okay? So if we try to rewrite this one, it will be the integral of 1 minus the square root of y over y times dy. Okay? I will replace this one here by this. So it will become, okay, let's forget this one first. This should be the integral of, from that, it will be 1 minus the square root of y raised to 1/2 all over, this is the square root of y, or just simply y to the 1/2. This is multiplied by dy. So in here, okay, be alert. Will it fall under the so-called power formula maybe? It might be, right? So if we assume that this falls under the power formula, it's a trial and error because the differential thing we could verify it. If just in case after the taking the differential, it's not exact, okay, our assumption is wrong. But let's assume for the meantime that this falls under the power formula. So I will let u to be equal to 1 minus the square root of y. The one inside this 1 half here. I will let this one to be u, right? So I will let u equal to 1 minus the square root of y. I will try to verify du. Du will be equal to, differential of 1 will be 0. The differential of the square root, it will be dy over twice the square root of y, for square root. But if you don't want the square root formula, you can use the so-called power formula for differentiating. It's still the same. What will come out will be a minus dy over twice the square root of y. And if we try to observe this one, okay, it seems it is similar to this dy here over this square root of y. We are only missing 2 plus this negative sign, right? So our assumption that this falls under the power formula was correct. We need only to insert some correction signs and some coefficients for it to fall under the so-called exact differential. So I will place it here. This given integral can now be written as the integral. This is u to the n, and this will be du, right? Our du emanates from this, right? It is negative dy over twice the square root of y. Okay? Without this negative in 2, it's the given problem, right? But for it to fall under the so-called power formula, we must have to contradict this negative sign. So I will place negative sign over here, right? And I will multiply the outside of the integral by the reciprocal of 1/2. The reciprocal of 1/2 is actually 2. Okay? That is under, what is reciprocals under Collins algebra. So the reciprocal of negative 1/2 will be 2. Right? Because actually, if we try to multiply this one, if we try to place this one inside, this 2 here cancel with this, and a negative and a negative, it will now be plus. Right? So it's the original problem. But we can place a negative 2 outside for it to be integrable under the u to the n du. Right? So this will now be negative 2, the integral. Okay? This is u to the n, and this is du as per verification. Right? So this will now be negative 2, the integral of u to the n du, where the value of n is actually equal to 1/2. Right? And the integral of u to the n du, one of the formulas under integral calculus, it will be u to the n plus 1 over n plus 1 closed quantity plus a constant of integration c. Okay, substituting. This should be negative 2. U is actually 1 minus the square root of y. 1/2 plus 1. Our n is 1/2, right? So this is plus 1. All over 1/2 plus 1, close bracket, plus c. 1/2 plus 1 is actually 3/2. It always involves algebra. That's why our, what they call this basic thing under algebra, we are using here under integral calculus, higher mathematics. 1/2 plus 1. This is 1. So you multiply this by 2 over 2, right? You don't change the value. So this is now 2 and 2. So under one common denominator 2. This is 1. 2 times 1 will be 2. So what comes out is actually 3/2. So 1/2 plus 1 is actually 3/2. So this is 1 minus the square root of y raised to the 3/2 all over 3/2 plus c. Okay. We multiply this by 2 over 2. Right? So what will come out? No. Sorry for that one. Under the denominator, there's a fraction, right? So this will be multiplied by the reciprocal of 3 halves. This is 2/3. Okay, to change the operation from division to multiplication, so we remove this one now. So negative 2 times 2 will be negative 4. This is over 3 times 1 minus the square root of y raised to the 3 halves plus c. So it always involves algebra, guys. Okay? So actually the integration process is just part of the solution, but majority of the simplification involves algebra, and in here it involves laws of exponents. Okay, good morning from Los Angeles.